A man starts walking. He walked 2 kilometers in the first hour. Then he walked two-thirds of the distance of the previous hour in each next hour. If he walked continuously, how long could he walk maximum? Okay. So the question is telling me a man starts walking. Okay. He walked 2 kilometers in the first hour. So a distance of 2 kilometers is traveled in 1 hour. Okay. That means 2 kilometers is traveled in the first hour. Then he walked two-thirds of the distance of the previous hour in each next hour. So the question here implies that with each passing hour, two-thirds of the previous distance is traveled. So two-thirds of the previous distance, which is 2, this much is traveled. Then again in next hour, again two-thirds of the previous distance is traveled. So two-thirds of the previous distance, which is 2/3 into 2. Okay. Then again in the next 1 hour, again two-thirds of the previous distance is traveled. Okay. Two-thirds of 2, and this happens till the infinity. Okay. This happens till the infinity. And the question is asking us, if he walked continuously, then how long could he walk maximum? That means we are asked here, what is the total distance he will travel? Okay. This is what we are asked. So let's do that. Let's calculate the total distance. Total distance will be the sum of all these distances, right? So it will be 2 plus two-thirds of 2 plus, I can say that this is 2/3 square, right? 2/3 square of 2 plus, here we can say that it is 2/3 cube of 2, 2/3 cube into 2, and this happens till the infinity. Okay. Now let's take 2 common from each term. Okay. Let's take 2 common here. So we get 2 is taken common, so we are left with 1 plus 2 is taken common, we are left with 2/3 plus 2/3 square plus 2/3 cube, and this is added till the infinity. All right. Now if you notice carefully, this looks something like a geometric progression, where this is a, this looks like AR, this is AR square, this is AR cube, and this is till the infinity. Okay. This looks like a geometric progression where A is 1 here and R is 2/3. Okay. If you are confused about how the R is calculated, it is calculated by dividing a term with its preceding term. Okay. So here 2/3 divided by 1 will be 2/3. Here 2/3 square divided by 2/3 will be again 2/3. Here 2/3 cube divided by 2/3 square will be again 2/3. Okay. So that's how you calculate the R common ratio. All right. Now this is the geometric progression, and you should remember one more thing here, that in geometric progression, sum of infinite terms, in geometric progression, the formula for sum of infinite terms is A divided by 1 minus R. This thing you should be able to remember. Okay. In geometric progression, the formula for sum of infinite terms is A divided by 1 minus R. So let's apply this formula in here. So we get 2 is outside the bracket, and inside the bracket we know A is 1. So we put 1 here, divided by 1 minus R. R is what? 2/3. So what do we get? We get 2. 1 divided by, LCM here will be 3, and 3 minus 2 will be 1. Okay. So again 3 goes in the numerator, so we get 2 into 3, which is equals to 6. So that means the total distance traveled will be 6 kilometers and this is our required answer. Okay. So here option B is the correct one.